Hey everyone, welcome back to Exi Academy. Today we are diving into one of the most important and powerful ideas in A-level maths, which is differentiation. And today we'll be doing differentiation part 1, that is in your AS level. And obviously we are starting right from the roots and also the first principle of differentiation. So let me start, but before that, if you are preparing for TMUA, I'm running batch classes as well as one-on-one classes. The classes are highly affordable and it's just at £8 per hour starting. And if you really want to enroll for a free demo, just email us at exactacademy@gmail.com. And also, if you're looking for GCSE classes or for any subject from year 1 to A levels, we provide classes. We have subject matter experts. So all you need to do is just book a free demo, and for that you just have to email us at exactacademy@gmail.com. So let me start with the differentiation. So let me start with the basic definition of differentiation, why we do it, what exactly it is. So differentiation is a mathematical process that tells you how a quantity changes with respect to another one. Or if I have to say in much more simpler terms, I would say that it actually helps you in finding the rate of change of a particular variable, or it basically gives you the slope of a function, or we can say slope or gradient of a function. Say for example, we have two variables and on 2D space, this represents x and this represents y. So how y is changing with respect to x, that's actually your slope. You know what we do if we have a straight line, how do we find the slope of a straight line? Or I could say, how would we find gradient of a straight line? We take two different points, A and B, and we calculate the change in y over change in x. Change in y over change in x is what? How much y is changing with respect to x. That's the meaning, and that's what differentiation is all about. So differentiation is, it helps in finding change in y over change in x, which is same as y2 minus y1 over x2 minus x1, that is the slope. Geometrically, we find it by drawing the tangent. For a straight line, we just have to pick 2 points because the gradient, the slope of a straight line remains same throughout. That means it doesn't matter which 2 points will you pick, they'll always give you the same answer. But in terms of a curve has different values or different gradient at different points. So that means, suppose this graph is actually in between displacement and time. So gradient of displacement and time will give me velocity. How I got to know about this? Because we know slope is how one variable is changing with respect to another variable, or y2 minus y1 over x2 minus x1. That means change in y over change in x. What is there on y-axis, which is displacement? That means change in displacement, how much a body is displacing, over what is there on x-axis, change in x, right? That means here it's time. So time, and we know displacement over time is velocity. So that's why the gradient will give me the velocity for displacement time. If the curve is like this, it's basically a curve, not a straight line. So it means the value of the velocity is different at different points. Geometrically, I can find it by drawing the tangent. That means if I'll draw this tangent like this, so it tells me the value at this point. So I just have to calculate the gradient of this tangent, and that will give me the velocity at this particular point. So whatever the point I want to calculate, the velocity at that particular point, I just have to draw the tangent at that point. Say for example, if I want to know this, say for example, the time here is 7 seconds. So I want to know what will be the velocity at t equals 7. So that means this would be my point, and I have to draw a tangent over this one. Then I have to calculate the gradient of this and I'll get to know it. This is a geometrical interpretation which is harder, obviously, because say for example if I want to know at 20-30 points I have to draw tangents, different tangents, which is not that easy, and for that we go for differentiation. So what can I write about differentiation? Like in terms of mathematical definition, I can say if we have a function f of x, obviously instead of writing y, I'm just using the function f of x, then its derivative, which is f dash x. It's important, you should know the notation. Either we use df over dx or dy over dx, or we use f dash x. It's both the ways, both represents the differentiation, and this tells us that how fast f of x is changing, because this is y. So f of x is changing as x changes. That means when one variable is changing, how much or how fast the other variable is changing. And second one is the instantaneous, that means at that particular instant, rate of change of f of x with respect to x. That's how you can define it. Now let me see what is a first principle. Now the first principle helps us in finding the differentiation. We want to calculate the slope of a curve at a single point, which is called tangent, and that we are trying to do with the first principle. That means not by geometrical method. So that means, say for example, if I want to calculate the slope at this particular point, geometrically I told you it's very easy. You just have to draw the tangent at that particular point and then you can calculate the gradient of that tangent. But mathematically, I mean algebraically, if I tell you how to do it, that's not easy, because we are aware of only one point. To find the gradient we should be aware of 2 points. This is a tangent. I get to know that okay, if I'll draw the tangent I'll get the slope. But to calculate the slope I should know 2 different points, and I'm aware of only 1 point. That's a problem. Only they have given this point, let's say 1,2, whatever the value, but we have only 1 point. So that creates the problem, and for that we will start with a chord. A chord is a straight line joining 2 points on the curve. The slope of the chord is something we can easily calculate, because for the chord we are aware of the 2 endpoints. So that when I'll draw the chord, let's say this be our chord, and the 2 points are A and B, and we are aware of these 2 points, and it will give us an average rate of change between the 2 points. So let's say B is x, the coordinates of B be x and f of x. I'm again saying instead of using y, I'm using f of x. And this will be because B and A are separated by some distance. Obviously, x are different and y's are different. So let's say that x of this and this are separated by h. So the value of the coordinate of x, the x coordinate of A will be x plus h. And similarly, y will be f of x plus h, obviously. And now we can calculate the gradient of A to B, which is y2 minus y1 over x2 minus x1, or I can say dy over dx is what? In this case, slope is what? Change in y over change in x. This represents the, keep that in mind, it represents average rate of change. At particular point we'll get to know instantaneous. For greater one it would be average. So like till here it represents the slope y2 minus y1 or x2 minus x1. There's a difference if I'm taking 2 points and calculating the gradient, that will give me the average value, whereas if I'm trying to find that particular point, it will give me instantaneous value. Now we know that, let's say A represents our y2 x2 and B represents x1 y1. So for y it will be f of x plus h minus f of x over, and x2 is x plus h and x1 is just x. This will become f of x plus h minus f of x over h. X and x will become 0 and will become h. The important point is why we have started with a chord, because we know the distance between them that we have taken is h, right? It's separated by the distance h. If we'll make h 0, that means A and B will overlap on each other. And in that case, they will become a tangent. That means when A and B will become one point like this, in that case, they will become just a single point, and that single point will give us the slope of that particular point, that slope of that tangent. And in this way, what we are actually doing, we are actually converting the chord into tangent. And how is it? When 2 points will become single point. And how the 2 different points will become a single point? If h will become 0. And that's why I'll write h tends to 0. That means when it finally reaches to there, we'll get dy over dx. So by first principle, dy over dx is f of x plus h minus f of x over h tends to 0. This is your principle, first principle. Now let me try to do some questions. This f of x represents all the types of function. It can be trigonometric, it can be logarithmic or exponential, algebraic functions. Any functions, if you put that value in this particular first principle, you'll find the derivative of that particular functions. Obviously you will be provided with the formula sheets, or it's easy, there are so many easy formulas, you can easily learn them. Those all formulas, though all derivatives are actually derived from this first principle. So we'll be doing some questions. Now question is, we have to find the derivative of y is equals to x to the power of n, or I can say f of x is equals to x to the power of n by first principle. So whenever we have to do it by first principle, the first thing is write down the first principle, which is f dash x or dy over dx equals f of x plus h minus f of x over h, whereas h tends to 0, that's the limit. Now it's given f of x is x to the power of n. So that means f of x plus h is what? That you just need to sub in the value of x as x plus h. So in this function, in place of x, I have to write x plus h whole to the power of n. So just put it here, you'll get x plus h whole to the power of n minus x to the power of n over h, limit h tends to 0. Now x plus h whole to the power of n, this n can be any bigger value, 20, 30, 40, which is not very easy to expand, but we can do it by binomial expansion. If you are not aware, I have already made the video, you can go over it. So this is how we can use the binomial expansion to expand x plus h whole to the power of n, that is x to the power of n plus nx to the power of n minus 1 h plus n times n minus 1 times 2 factorial x to the power of n minus 2h squared, and so on, minus x to the power of n. So I'm just substituting this value here. It's a long series, I'm not writing the whole one. So it will be x to the power of n plus nx to the power of n minus 1h plus n times n minus 1 over 2 factorial, which is 2, x to the power of n minus 2h squared, And then there is minus x to the power of n over h, and limit h tends to 0. Clearly you can just cancel this out. So x to the power of n will be 0 now, and then remaining would be limit h tends to 0. This will be nx to the power of n minus 1h plus n times n minus 1 over 2 x to the power of n minus 2h squared plus n. The n would be h to the power of n. The and term is over h. You can clearly see I can take out h as common. So if I take out h as common from the numerator, this will give me n x to the power of n minus 1 plus n times n minus 1 x to the power of n minus 2 h. Now this square will become 1 because I have already taken out h as common. Then the next term, all the h will become 1 lesser, the power will become 1 lesser as we have already taken out h as common. So at the very end, in place of h to the power of n, it will be h to the power of n minus 1 over h, and I can cancel this out. Limit h tends to 0, that means at the very end when you are done with simplifying, always try to cancel this h, because obviously when you put h there it will make it a very bigger number, a mathematical error obviously, and for that we always try to cancel out this h, and that can be done if you take out h out as common in numerator. After we are done with simplifying and everything, in the remaining portion that's remaining here, which is just this one, I need to sub in the value of h as 0. That's the meaning of h tends to 0 limit. That means at the very end we have to substitute h as 0. And in this clearly I can see, except for the first term, every term contains h. That means doesn't matter how many terms if I'll write, they all will become 0 because they all have h in it. So after substituting, I'll get nx to the power of n minus 1. This is actually derivative of x to the power of n. So if f of x is x to the power of n, then df over dx is nx n minus 1, and that's how you can easily calculate the derivative of any function. Let me do one more question. So now we have to find the derivative of f of x equals x squared by first principle. So same thing, I told you whenever you have to apply, you have to write down the first principle, which is f of x plus h minus f of x over h, whereas h tends to 0, that's the limit. So we know f of x is x squared. That means f of x plus h is x plus h whole squared. That's the meaning of it. Whatever there's inside the bracket, that value we have to substitute in place of x. So f of x plus h is x plus h whole squared, and f of x is x squared over h, and this limits tends to 0. We have to simplify, try to cancel out the bottom h, and then sub in the value of h as 0. These are the few steps that you have to keep in mind while finding the derivative of any function from the first principle. So x plus h whole squared, that means x plus h times x plus h, and when I expand the bracket, I'll get x squared plus h squared plus 2hx minus x squared over h. X squared minus x squared will become 0. We're left with h squared plus 2hx over h, and tends to 0. I told you, try to cancel out the bottom h, so I can take out h out as common from the numerator. Remaining would be h plus 2x over h. I can cancel out. And at the very end, once I'm done with all simplification, I just need to put h equals 0. I'm remained with h plus 2x, and when I'll substitute h as 0, it will give me 2x. So the derivative of x squared is 2x, And we just have derived the formula from the first principle of x to the power of n, where n can be any value, is nx to the power of n minus 1. So nx to the power of n minus 1, that's the formula, and that's a differentiation of x to the power of n. So if I'll use the same formula rather than first principle, if first principle is not mentioned, we have to use this formula. And here is clearly 2. So if I'll put that here, 2x to the power of 2 minus 1, which is 2x. So which we can see is the same one. So that's it for today. In this video, we were supposed to do the first principle, and in the next video, we'll be doing questions on first principle. So that's it for today, and same if you are looking for online classes, live one-on-one or group classes, all you need to do is just email us at exactacademy@gmail.com. That's it for today. Bye everyone. Take care.